Okay, let's get into one of the biggest and maybe most secret projects in all of modern history, the Manhattan Project.
It really was. This wasn't just some small lab experiment. It was a massive research and industrial program that the U.S. launched right in the middle of World War II.
A race against time, basically?
Exactly. The mission was, well, it was terrifyingly clear: build the world's first atomic bomb. The project really got going around 1939.
And the motivation, it wasn't just about creating a powerful new weapon, was it? It was driven by a very specific fear.
Oh, absolutely. The fear was that Nazi Germany was already working on one.
Yeah.
Scientists, a lot of them refugees who had fled Europe, understood the incredible power locked inside an atom.
So they warned the government.
They did. They said if Germany gets this weapon first, the war could be over, just like that.
And so President Roosevelt gave the green light and the funding. The idea was to get there first for national security and to end a horrible global war as fast as possible.
Yeah, and the scale is something that's hard to even imagine. We're talking thousands of the world's best scientists and engineers all working under this blanket of secrecy.
So much secrecy that most of them didn't even know what they were building.
Not at all. And the name, the Manhattan Project, it sounds so normal.
Right. Not very top secret.
Well, it's just because the project's first office was in the Manhattan Engineer District of the Army Corps of Engineers in New York City. The name just stuck, even when the project spread all across the country.
So before we get into the secret cities and the leaders, we have to talk about the core science. For anyone who's new to this, what exactly is nuclear fission?
Okay, so think of the center of a heavy atom, like uranium, as a really tightly wound spring. Fission is what happens when you hit that nucleus with a tiny particle.
And it just snaps.
It splits. It breaks into two smaller pieces. And when it does that, it releases a huge burst of energy. But, and this is the crucial part, it also releases more of those tiny particles.
Which then go on to hit other atoms.
Exactly. You get a chain reaction. If you control it, you get nuclear power. If you let it happen all at once, you get a bomb.
And this is where a physicist named Leo Szilard comes in. He's the one who first figured out this chain reaction could be used for an explosion.
Yeah, and he was terrified that the Germans were working on it. He was the one driving the science, but he knew he needed someone with real influence to get the president's attention.
So he went to the most famous scientist in the world.
Albert Einstein.
Oh.
Szilard convinced Einstein to sign a letter to President Roosevelt explaining how powerful uranium could be.
It's interesting because Einstein himself was a pacifist.
He was, and he never actually worked on the project. He wasn't even given security clearance. But his famous equation, E equals mc squared, that was the bedrock theory. It proved a tiny bit of mass could become a huge amount of energy.
So his signature on that letter gave it the credibility it needed.
It got the project, its initial funding, it got the ball rolling.
Okay, so the science is approved. Now you have to actually build it. And that's less about theory and more about logistics. That's where General Leslie Groves comes in.
Groves was the perfect man for the job. Intimidating, but perfect. He was in the military head of the whole project, super strict, incredibly efficient.
He'd just finished building the Pentagon, right?
He had. So he knew how to manage a massive construction project on a tight deadline better than anyone. He took this science idea and turned it into a giant, continent-spanning industrial machine.
And he was the one who insisted on that extreme secrecy.
That was his genius, really. Compartmentalization. He split the work into so many different pieces in so many different places that almost nobody knew the full picture.
So a worker in one factory had no idea what the person in the next state over was doing.
Exactly. It was all on a need-to-know basis. Crucial for stopping spies.
But Groves, the military organizer, he needed a scientific director. Someone to manage all the brilliant and probably difficult physicists.
And that person was J. Robert Oppenheimer. He's often called the father of the atomic bomb.
He was a theoretical physics professor. What made Groves choose him? He didn't have much management experience.
No, he didn't. But Groves saw that Oppenheimer had this unique ability to speak the language of all the different sciences. Physics, chemistry, engineering. He could connect the dots.
And his job was just monumental.
I mean, think about it. Go find the smartest people in the world, bring them to a secret location, and have them solve a problem that's never been solved before, all with the pressure of a world war on their shoulders.
It wasn't just about the physics, it was about the engineering. How do you actually design a device that will work?
That's it. How do you make it small enough to fit in a plane, but powerful enough to end a war? That was Oppenheimer's challenge.
And to meet that challenge, they had to build, well, an entire secret world. 3 secret cities, really, each with a very specific job.
Let's start with the brain of the operation, Los Alamos, New Mexico.
This was the design lab, built on a remote desert mesa, basically out of nowhere. They took over a boys' school in 1943 and just built a town.
The isolation was key. It was easy to guard, and thousands of people lived there, scientists, their families, in a community that wasn't on any map. Their mail went to a P.O. box, so no one knew where they were.
And their job wasn't to make the nuclear fuel, it was to design the bomb itself.
Right. How do you make it go off at the exact right microsecond to get the biggest explosion?
Right.
That was the core problem they had to solve at Los Alamos.
Okay, so to get the fuel for that bomb, we have to go to the other 2 cities. Let's start with Oak Ridge, Tennessee.
Oak Ridge was just a massive, sprawling factory. Its only job was enriching uranium.
And we should explain that. Natural uranium isn't actually useful for a bomb, is it?
No, most of it is an isotope called uranium-238. What you need is the very rare isotope, uranium-235. It makes up less than 1% of natural uranium.
So enrichment is the process of separating the rare, useful atoms from the common ones.
It's incredibly difficult. They're almost identical. So Oak Ridge was filled with these enormous factories running 24/7, using more electricity than New York City. Yeah, and the thousands of workers there, they were just watching dials and turning knobs. They had no idea they were making fuel for an atomic bomb. That enriched uranium was for the first bomb, which they called Little Boy.
Okay, that's one type of fuel. For the second, we have to go across the country to Hanford, Washington.
Right. Hanford's job was to create a whole new element, plutonium.
Plutonium doesn't really exist in nature.
Not in any usable amount, no. So at Hanford, they built these huge nuclear reactors along the Columbia River. They needed all that water for cooling.
And inside the reactors?
They bombarded uranium with radiation, which transmuted it, changed it into plutonium. The work was incredibly dangerous because of all the radioactivity. They had to invent remote-controlled tools to handle the material from behind thick lead walls.
And this plutonium was for a completely different, more complex bomb design.
Exactly. It would be used in the very first test and in the second bomb dropped during the war.
Which brings us to the moment where all of this theory and all of this work becomes real. The Trinity test.
The world's first ever nuclear explosion. July 16, 1945, in the New Mexico desert. They were testing the plutonium bomb, the one they had nicknamed the Gadget.
The scientists watching from bunkers miles away. They couldn't have been 100% sure what would happen.
Not at all. There was a real, if tiny, fear that it might not work, or even that it might set the whole atmosphere on fire.
So they set it off on a steel tower right before dawn.
And the result was just unbelievable. A flash of light brighter than the sun, a shockwave felt 100 miles away. And that mushroom cloud, rising 40,000 feet into the air.
And the heat was so intense it melted the sand to a green radioactive glass.
They called it trinitite. The government put out a cover story, said an ammo dump had exploded. Yeah, but the scientists knew. They knew it had worked. The bomb was a reality.
Just 3 weeks later, they used it. The first bomb, Little Boy, made from the Oak Ridge uranium.
It was a simpler gun-type design. They were so confident it would work, they didn't even test it. On August 6, 1945, the bomber Enola Gay dropped it onto Hiroshima.
The explosion was equal to 15,000 tons of TNT. It destroyed the city.
The initial blast, heat, and radiation killed about 70,000 people almost instantly. It was horrifying.
And then 3 days later, the second bomb, Fat Man, the plutonium one from Hanford.
This was the much more complicated implosion design that they'd tested at Trinity. On August 9th, the target was supposed to be the city of Kokura.
But there were clouds, right?
Heavy clouds. The bomber couldn't get a clear view, so they diverted to their secondary target, Nagasaki. The blast there killed about 40,000 people.
And the devastation from those 2 bombs led directly to Japan's surrender.
It did. World War II officially ended on September 2, 1945. The project had succeeded in its goal of ending the war.
But its legacy is so much more complicated than that.
It's a total duality, isn't it? On one hand, it started the atomic age. The science led to things like nuclear power for electricity and new techniques in medicine.
But on the other hand, it kicked off the nuclear arms race. That fear and tension dominated global politics for the next 50 years. The ethical debate it started is still going on.
And those secret cities, Los Alamos and Oak Ridge, they still exist. There are now major national laboratories doing all kinds of scientific research.
So the Manhattan Project really stands as this pivotal moment. It's where science, industry, and warfare all came together to achieve this incredible and terrifying feat of engineering.
It completely changed the world. They solved the problem of how to build the bomb.
But they left the rest of us with a much harder problem: how to live with the power they unleashed.
And we're still trying to figure that one out.
Good luck with your studies.